Now we will talk about the advanced distance module and how to test this application example.
Yes.
Today is our ABB REX 640. So mainly in the we will follow the Omicron Ohm's law, as you know. So the first is test object. We will open the REX 640 test object, and as you can see here is the distance Rio file. Okay, so here is the system setting, which is can be expressed. I can explain one by one. Here is the line length in ohm. Okay, so it's 7.880 in ohm, and we have also this setting inside the relay, and I will show you this setting. And also there is a line angle which is 64 degree. Okay, and this line length, take care, it's in ohm, not in kilometer, because some relays express the line length in kilometer, and express line impedance is ohm per kilometer. So to get the value of the line total impedance, you have to multiply these two values, to find it the total in ohm. Then you have also the BT connection to be you have to define to be at the line or at the bus bar, and also the CT start point to be at the line or the bus bar. And as we explained, the effect of the BT connection and start point is affecting the directionality of the forward and the reverse zone, and the BT connection affecting the post fault characteristic for sure. If you have post fault state, it will simulate the BT connection or not based on the BT location. Okay, and here we have also tolerance for the time and for the impedance. So this tolerance is expressed by two ways. First way is relative as 1%, and second way is absolute value plus or minus. Okay, so the time 1% or 30 milliseconds, whichever is greater, it will take into consideration for result assessment. It's a tolerance based on the relay manual. So the difference between the actual trip time and the nominal trip time, it should be not exceed 1% or not exceed 30 milliseconds. It's for only this relay, but for other relays, you may have another tolerances. It's based on the relay manufacturer. Okay, and also we have also the same for the Z relative and Z absolute. So you have to define Z relative 5%, Z absolute like 100 milli ohm and so on. Here is the grounding factor, which we explained in our presentation. This grounding factor is very important in case of single phase to ground fault for precise fault location of the relay. Okay, so the relay should take in consideration this grounding factor to eliminate it from the total impedance measured by the relay to find out what is the precise location of the fault location. So this grounding factor can be expressed in three ways. Can be expressed in Z0 and Z1. And this way is depends on the relay manufacturer type. So some relay manufacturers express in zero sequence and positive sequence impedance. Some like Siemens relay for RE over RL and XE over XL, which is the ground reach over the line reach and the ground reactance reach over the line reactance reach, and so on. And also some relays it's magnitude and angle, as you can see, 2.8 and 0. Okay, and here also we have if we check this option, we have also to activate this calculation with RE over RL or XE over XL. Okay, we have also the impedance in primary. It will be selected automatically. Yes. Okay. And we have also impedance in primary values, and this option will be ticked only, will be activated only in case of ABB RED 670. It will make the conversion from Z0 to Z1 to RE over L or T over XL. But if you have different values, you have to specify it. Okay. Normal ways, if you selecting the BTL right for the your relay, like Siemens relay, it will be activated automatically, and it will get these values from the relay parameter setting. There is no need to enter it manually. Yes, no need to enter it manually or calculate anything. Okay. Just I give you an example. Here is the impedance in primary values. This one, it will be activated only in case of ABB RED 670 because it expresses the impedance in primary values. Otherwise, for all other types of relays, you can keep it as it is. And here we have also impedance correction 1 ampere over I nominal. And here, if you have a CT, not standard CT, which means the secondary side of the CT, not 1 ampere and not 5 ampere, suppose 2.5 ampere, this is not standard CT. So you have to activate this impedance correction to make correction of the impedance values based on the CT ratio. Then we have also another setting which is called zone. Not 1 ampere, not 5 ampere. As you can see, if you press the help button here, here is the impedance correction from secondary to primary values in case of the ABB relays, and here is the 1 ampere over I nominal. So if the nominal current of the relay is 5 ampere, the calculation of the impedance is treated differently by some relays. So if the impedance calculation equation uses multiple of nominal current to determine the impedance, the option impedance correction 1 ampere over I nominal must be selected. Okay. So if you need any help or any definition about any kind of parameters, like for example grounding factor, how to express this ground, and what is the effect of this grounding factor in case of phase to ground fault, you can check from the help button, and it will explain the effect of this grounding effect. Okay. Click help from here, and it will give you this parameters in this same page. Okay. Without searching, it will give you the same window. As you can see. You can navigate for sure. So here is the system setting. You can navigate for the zone setting, which we are going to explain, and so on. Okay. The second type of setting, we have zone setting. Zone setting, which we use to draw the characteristic, but if you are using the BTL, it will be drawn automatically once you import the relay parameter setting. Yes. So we have here like zone 1, zone 2, zone 3. So for this one, Z1, you can see the trip time here at 30 milliseconds, and here is the tolerance for the time and for the impedance, which we specify already here in the tolerance field. Okay, so if you change anything here, it will be automatically changed here. Yes, because it's gray, as you can see, it's gray. So you can you cannot change it from here. You have to change it from the tolerance field. Okay. So for zone 2, for example, we have 430 milliseconds. Zone 3, we have 830 milliseconds. But what if I need to review these zones? You can press edit. And as you can see here, you have many more values for many more lines, from 1 to 5 lines. And here also you have a predefined shapes, multiple predefined shapes. Quadrature, elliptic, moho. It depends on the relay type. You can select it while you drawing it, or it will be automatically drawn. Okay. So for the line 1, for example, now this is line 1. If you select this line 1, you will find this one in blue, which can be represented in 0, 0, and 338. For the line 2, there is a line 2. It's 2.9, 0, and the angle is 90. Okay. For the line 3, it's 2.9 and 0, yes, and it's parallel to the line angle. And the line 4, it's 180 degree, and the X is 6 ohm. And for the line 5, to return back to the origin, and with angle, this one is 30 degrees. So if you extend this line in mathematics, this angle also will be 30 degree. So 270 plus 30, it will be 300 degree. Okay, clear? The same for the zone 2 and zone 3. So for example, if you make it for the zone 2, it's the same here, but the R and the X reach is different. As you can see, 4.4, 9.2. So it's bigger than, for sure, zone 2 is bigger than zone 1 because it covers more length and more line impedance, more distance than zone 1. Okay. And the same also for the zone 3. So if you need to draw, you have to press new. And this is what we will take in our practice example. Okay. So now we click OK, and then we can go for the second part, which is the hardware configuration. So now we are following our Ohm's law. So in our hardware configuration, as you can see, you have to select the test set. Even if it's online in the device link, you have to select also in the global hardware configuration, and this selection is active from the test universe 4.40. Okay, so if you have test universe 4.40 or higher, yes, you have to select the test set inside the hardware configuration, even it's connected inside the device link. Okay. So we have to select this one, and we can press OK. And also give you possibility to work in offline usage. So if you have a project, for example, after 1 week, so you can select the CMC, which is not available right now with you, but you can implement the file as bare. We will work on this CMC. So it's working. It gives you offline usage for all these types of CMC. Okay, to just prepare your predefined test plan, and you can go connect the CMC and start directly. Yeah. So this is a feature of the offline usage. Now we have to define the voltage and the current. So I will use 3 voltage and 3 current, but we can keep it 6 for the next differential function. So we will press OK. Then we can go directly for the advanced distance module. From where we can insert here, click insert and select insert test module, and we can check advanced distance, as you can see. Okay, then we can press OK. So for example, we can press it now, as you can see here. And if you double click the advanced distance module, it will be automatically linked to the distance review file inside the test object. Automatically. Okay. So for example, here we have the short test, check test, search test. So we have 3 modes of test for the advanced distance module: short, check, and search. But we will get back to this 3 mode of test, but we will explain first the setting. So in the test model, you have to select which kind of model you are going to implement, like constant test current or constant test voltage or constant source impedance. So most of the relays we use constant current. Yeah, constant test current, and you can specify it to be 2 I nominal, like double I nominal, and so on, based on the relay characteristic. And also there is constant test voltage, which is not very common, and the constant source impedance can be used for the SEL protection relays. Okay, this is a very common setting for the SEL relays to use the constant source impedance. So for here, the I test is specified as 2 ampere, and it's linked as you can see. And if you just move the cursor, you will find out is 2IN, and the location is the Rayleigh device luminal values IN equal 1. So it's linked. It's linked here. If you click also link to X-ray, you can see this link clearly from here. So this value is multiplied by 2, which is I nominal equal 1 ampere multiplied by 2 is equal to 2 ampere. Yeah, okay. And here is the V maximum, and V maximum now we specify to 120, which is 1.2 from the V nominal, as you can see. Just to move the cursor and make it here, there is a factor here called allow reduction of I test. This allow reduction of I test will vary the V maximum depends on the new impedance, but with fixed constant current, with fixed test current. Okay. So this one, it will give you this facility to allow reduction of I test. So it will reduce the I test, and it will fix the voltage until it gets the value of the impedance. Reduction of I test. Okay. Then we have also the fault inception, can be from random, which is a default setting, can be from the maximum offset, which is at 90 degree in sinusoidal waveform, will detect the maximum offset, can be zero offset, can be a fixed angle. Zero offset, which is zero crossing in the sinusoidal waveform.
Okay.
So it can be maximum offset, which means the highest amplitude of current. Can be zero offset when it's crossing to zero. The sinusoidal wave is crossing to zero. Can be fixed angle like at 30 angle or 40 degree and so on. Okay. And there is a DC offset if you need to superimpose a DC component on the sinusoidal waveform, as we explained. Here is the load current. If you need to specify a pre-fault load current, you can activate it and you can put it for a value, and it will inject it for a duration equal to the pre-fault time here. Okay, and you can ignore the nominal characteristic. If you press ignore the nominal characteristic, it will ignore this tolerance bands and tolerance lines, and it will give you the actual reach. And this one is very important in case if you don't if you are not sure about the characteristic, you can allow the CMC to detect the boundaries of zone 1, boundaries of zone 2 without any assessment, because you don't know what is the values actually. Okay, so you can use it. And here is the search interval, which is 200 milliohm between two adjacent test shots. Okay, here is the search interval. Here is the time for the pre-fault, maximum fault, and the post-fault. The main important here is the maximum fault to be more than the most expected time. So if I have 4 zones and the most trip time is 1.8, for example, so this value should be more than 1.8, like 2 seconds, 3 seconds, and so on. And here is a time reference for the trip time measurement. It can be you have 2 options. Can be fault inception, depends on the CMC injection current and voltage, or it can be from the starting. If you have a start contact from the relay, simulate the pickup of the distance protection. You can use it to initiate the timer, and it will be triggered by the trip contact. So it will give you exactly the trip time in the relay. Yes, yeah, between start and trip. This time you can find it also in the disturbance recorder in the relay itself, so you can compare it. This is the actual trip time. Okay, and you can keep it as default fault inception. And we have also extended zones in case of you have extended zones for switch on to fault, for example. So you can activate this extended zone options. We have also switch off at zero crossing. This is very good and very useful for the CMC. So the CMC, if the fault happens at the maximum amplitude of current and maximum amplitude of voltage, which is the maximum offset, so the CMC will not interrupt the current and voltage injection until the next is natural zero crossing of the sinusoidal waveform. So it's decrease the hazard and improve the safety of the CMC. Okay, and for you as a user, for sure. This is the help button. Here is a switch of zero crossing. This means if the fault happen at the maximum offset of the current or the voltage, so the CMC will detect the trip time, but it will not stop injection until the next zero natural crossing of the voltage sinusoidal waveform. Yes, this is only for the CMC safety and for decrease the hazard for the user as well. If you can read it, select this option to stop the CMC to set output current at the next zero crossing after the opening of the circuit breaker. So if the circuit breaker is tripped, it will wait until the next natural zero crossing. And here the switch of zero crossing option is enabled only if you select the option BT connection at live, which means for use for the voltage also. Yes, it needs to cut the voltage. Yeah, because if the circuit breaker is tripped, this means there is no voltage on the line. So it will cut the voltage as the next zero crossing as well. Okay, and if you have the BT connection as a bus bar, the option switch of zero crossing is disabled. So it's used for the voltage amplitude voltage sinusoidal waveform. Okay, because if we are using the bus bar, So this switch off at zero crossing is disabled. And this universe doesn't support switching off at zero crossing if the voltage is not set to zero at switching. Okay? Clear?
Yeah.
So any setting, it's very easy. Just press the help button and read the. It's very short explanation, and it will give you the full meaning.
Yes.
Okay. Then we have also search resolution in relative and in absolute between two test shots and between. This is for the search test, as we will see next, inshallah. We have also the trigger option. Now we can use which one start or trip. So we will use the trip contact for all three zones. Okay, and it's all for sure because only used one contact, which is a trip one. Here is the binary output. If you need to simulate like circuit breaker close, circuit breaker open, DKMCB trip, and so on to check the directionality and the blocking function. Okay, so here is the ribbon as we explained yesterday, and we have also a predefined check test here. So we have defined some lines to check the check test, which is here. Okay, so we have three modes. We will explain one by one and how to use this one. This check lines simply check the 1 point in zone 1 and 1 point before and 1 point after. Actually, if this one is 5%, as in our example, so this one is 95% from zone 1 and this one is 105% from zone 1. But this point, this values, it will be like 94%, which is 1% before the tolerance starts. So it will be 94 and 106. So it will check the boundaries by using two test points, two test shots, one before, one after. Okay, as you can see here, 2 points for zone 1, 2 points for zone 2, 2 points for zone 3. And if you are zooming, if you use the zoom mode here, so here is the 2 points. Okay, so it will not clear from here. We can go for the zone mode. So here is the same for zone 1, same for zone 2, same for zone 3 at different angles, as you can see. So we have make line at 64, which is the line angle. We have also specify one at 90 degree and one at 30 degree. Okay, and here is the origin of the line, as you can see from this one. This the origin is here. Okay, which is can be specified by the R and X or by impedance and angle. Okay, and the length. Here is the length should be can be in ohm or can be relative to the line length or to the zone 1 or to the zone 2 or to the zone all zones, maximum zone reach will detect from the all zones. So you can make it relative or you can make it in ohm. Okay, this line is 13.32. We can make it relative and we can make it from the all zones. We can make it like now. So it means this 169% from the line length is equal to 13.32. If you change it to zone 1, it will be 9. And as you can see here, the line now is very short and it's not reached to the zone 3. And it's not reached also to the boundary of zone 2. So you can keep it or you can change it based on the characteristic. Or you can make it all zones, which is 19 ohm. Or you can remove the relative and keep it as it is. Okay, clear?
It's clear.
So here we are ready to test. So it's better to do a wiring check for sure for injecting current and voltage before start the testing. So then you can start the testing directly. So it will check 2 points, one before, one after the boundary of the zones. Also you can see the report view at the end of the test. So the line 1 is assessed as pass, all the point is good. So this point will be tripped with 0, this point will be tripped with zone 2, which means there is a boundary line here. So it's a very quick test. If you are working as a maintenance engineer and you need very quick test to check the boundaries, you can use this check test because it's very fast. Only 2 points before and after, just to make sure there is a boundary here. There is a zone boundary here, differentiate between this time and this time. So it's good. But for more accurate tests, you can use the search lines. So this for Z2. So you can use it here. For example, this one is used for Z2. You can make also the same point here, take copy, and for example, put it for the 3 line. So now we will do the line 2, line 3, and 3 line together. You can do the same also for line 2 is, and so on. Okay. Then you can select start. It will finish the L2, L3. Then it will go directly to the 3 line, and now it is a single line to ground. So we have here also different views. Here is the impedance view. We have also the time signal view, such as a complete file with the time trip signal view here. And also we have the phasor view for the voltage and the current quantities. Yeah. And also in positive and the symmetrical component, positive, negative, and zero sequence component for voltage and current. We have also Z by T. Z by T, as you can see here, this is the Z1, here is the Z2, this is the Z3, and also we have also the last view, which is the report view. So this is the report view. Now we finished all the impedance view. You can see the report view from here, and you can select which field you need to be done, or you can define your test report. So for example, I don't need Z by ZT, I need only the characteristic with the shots. You can define it easily from the report settings, then define, and you can remove it from here. Yes, you can remove it like this, and you can keep only the test result, like shot, check, and search test, and that's it. So it will be very nice and very compact at the same time, but it takes time to reflection. Yeah. Now it's very short, as you can see. You can remove this also, short details if you need. You can remove the cursive data details and so on. So it will be printed like this. Okay. The next test is the shot test. So the shot test, we have you have to define some test points inside each zone, and it will compare the actual trip time with the nominal trip time. Okay, as you can see here is the impedance view. So here is the shot test, and for the line 2 as well. And you can make the same here. You can append shot, for example here. So it's appended now, like this, in each zone. Or you can append multiple shots. From here, append shots, and start select line to line, 3 line, and so on. And you can we can make it here. It will be appended in 3 line and 3 line, because I select 2 phase types, 2 fault types. Okay, so you can append shot manually, or you can append shots. Okay, then you can select start. You see, we make like a ramp here, then it will check this. Yes, the tripping time, and here is the T nominal, 30, 430, 830, compared to the T actual. Here is the T actual. Okay. So here is the deviation, 64.33. Did you see this one?
Yeah.
In deviation, in relative value, but still in the absolute value is bigger. Yes, that's why it's assessed as bus.
Yes.
Because for the zero tripping zone, the tripping time is 0 or 20 milliseconds. So the relative here is meaningless. So you have to take in consideration the absolute one, the absolute ohm value. Okay. And here also the report view, if you like to check it. And here is the points which we already make it right now. Yeah, here is the search test. This one, it takes more time, but it's more accurate because it detects the intersection between the search line and the zone boundaries. Okay, with a very precise approaching and very precise measurement. For example, we have now defined 3 search line. You can append more search line for sure. So for this, for example, I can append here. I will append search line, as you can see, and here is the angle. I can make it 0, for example, the origin. Okay, and with angle like 45 degree, and with like 15 ohm. Then you can append this search line. So this search line, yeah, you can make we can do it like relative to be better.
Yeah.
And I recommend to make it relative all the time, because if you have changing the relay parameter setting, it will be automatically relative to the line impedance, and it will give you the search line. No need to adjust it. Yes, no need to adjust it every time.
Yeah.
Okay, so if the line impedance is 5 ohm, it will be relative to the 5 ohm. If it's 20 ohm, it will be relative to the 20 ohm. Okay, so there is a line, and also you can append search line one by one, or you can append multiple search lines. Which means multiple search lines we can check for here. We can check multiple test lines for many more fault types in the same time, or you can append quick. Quick means, for example, if I'm using quick, as you can see, it gives me three lines: one at 0, one at 90, one at line angle. Okay, this is a quick mode. For example, also you can append a sequence. This sequence you have to define the start angle. For example, I will start from 0 up to 90. Okay, every 30 degree I need a ramp. I need a search ramp. So I will have total 4 lines. Okay, and the length we can make it relative, or we can make it like 20 ohm. So it will give me 0, 30, 60, 90. Okay, so you have different ways to define and to put your search ramps. Okay, then you can select start. We'll take one by one for sure. You see here, if you make zoom mode here, it will give you the approaching. I will show you in the zone 2. Yes, see, it's coming here, and here is zone 3. It will approach, go after and before approaching the most precise intersection until it gives you the most precise value. And based on this intersection, it will assess the results based on the nominal impedance. Now it's searching for zone 3. We'll finish this search ramp, but we'll go for the next search ramp. Just will take some time. Here is the quick mode at 3 angle, 0, 90, and line angle. So I will stop the test right now. So we finished the shot, we finished the check, we finished the search test. Okay.
Yeah.
So this is how to use the advanced distance module to check the impedance characteristic for the ABB REX640 relay.